I'm going to start this problem off with some very basic understanding what standard deviation is. To give you as basic of a definition as I can get, I would really say standard deviation is how far or how spread out the numbers are compared to the mean. So let's take an example. On the left side here, I have sample A and sample B. Now, again, I'm going to repeat the definition. The definition of standard deviation for our purposes for now is how far spread out the data is compared to the mean. So if I look at these numbers, and if I look at these numbers, I think it should be pretty straightforward to tell which one's more straightforward without even calculating the mean right now. Doesn't it look like this set is more spread out because the numbers are really, if you look at from the 2 to the biggest number, 70, they're relatively spread out compared to this one. But now I calculated the mean already. The mean for this set of numbers is 10, and the mean for this set of numbers is 25. So over here, if I look at the number from 6 to 15, it's relatively closely lumped by the 10. 6 is really not that far, 15 is really not that far. So you would say the standard deviation of this sample is smaller compared to this one. Because if you look at this one, the mean is 25, but you have a 2, and you also have a 70, 60, 30. See how these numbers are a lot further away from 25? So standard deviation of sample B is going to be larger. We're going to apply that same exact logic to the question over here. The question is asking us to compare graph A and graph B. This line is a line of best fit, so you really kind of can look at this as your mean or the average, this particular line. And using that same concept, the question is saying which of the following statements is true. So let's check out answer choice A. Graph A has the same standard deviation as graph B. That wouldn't necessarily be true because the dotted numbers over here are very different than compared to graph B, so they're really not the same. Let's check out B. Graph A has a smaller standard deviation than graph B. Now, if you look at graph A and graph B, graph A, these points are a lot more spread out compared to graph B. Graph B, everything for the most part seems it's very lumped together. But graph A, the numbers are a lot further away from that line of best fit. So that tells me that the standard deviation here has to be larger. And over here, it's going to be smaller. And the reason one more time for that is because everything is lumped very close to each other, while over here everything is spread out. And going back to this example, if the mean is 10, the numbers are relatively close to that 10, so this has a smaller deviation. So similarly, graph B will have a smaller standard deviation. So graph A has a smaller standard deviation, wouldn't make sense. It would have to be graph C. Graph B has a smaller standard deviation than graph A.